In this lesson, we're going to look at the relationship between the gradient of a line and the angle the line makes with the x-axis. So if you look at this diagram down here and we look at this line, then we can see that we have created a triangle with the x-axis. Now on the triangle, when you talk about gradient, you think of the change in y's over the change in x's, or delta y over delta x, or rise over run, whichever way you look at that. But you can also think of it as a triangle with an angle in here. And if we were thinking about trigonometry, we would think that that side is opposite the angle, so that's called opposite, and this underneath would be called the adjacent. This would be called hypotenuse, but we're not interested in that at the moment. So we know that the tan is equal to opposite over adjacent, which is the same relationship as delta y over delta x. So from that we can say that the gradient is equal to delta y over delta x, which is also equal to tan theta. So gradient is equal to tan theta. And this helps when we're trying to find that angle between the x-axis and the line. A wee point to make is from these diagrams here, the angle that we can find out is only from the positive direction of the x-axis. It doesn't calculate the other side. You would have to subtract from 180 to get that angle. So let's look at an example. Find the angle of the line joining A 0.34 and B 6.9 makes with the x-axis. So first thing we have to do here is we have to work out what the gradient is. We do that by subtracting the y's and dividing that by subtracting the x's as well. So 9 take away 4 over 6 take away 3. 9 subtract 4 and 6 take away 3. You could do 4 take away 9 and 3 take away 6, but that would create negatives. Try and avoid it if you can. So that would give us 5 over 3. So next, m equals tan theta. So tan theta is equal to 5 over 3 because we've already worked out the gradient. If we inverse tan 5 divided by 3, we get 59 degrees, and that would be our answer.